This is note-taking guide 4.2. It's called square root functions and their graphs. So in 4.1 we learned how to find the inverse function for a graph or for an equation. And today we're just going to start by doing that same thing. So on this first problem it asks you to find the inverse of f of x equals x squared. In order to do the inverse, the very first thing we do is we make that f of x value a y value, and then we interchange x and y. That means we make the y the x, and we make the x the y. So we rewrote the equation the exact same way that it was, except for interchanging x and y and making x y and making y x. Then the last step to do is resolve the equation for y. So I need to get y by itself again, and the y has a squared term on it. In order to get rid of a squared, I do the inverse operation, which is square root. So I get the square root of x on one side, and then the squared and the square root cancel each other on the other side to get y. But if you remember up here at the beginning, our y was really a f of x value, so I need to rewrite that so that it's an f of x value. And then just be reminded that it wasn't the original f of x function, it's the inverse function, so we put the -1 on it to imply that it's the inverse of the original function. Okay, same thing here, finding the inverse. This time it's just a little bit more complicated in the equation. But it works the same way. We know that our f of x value is our y value, so we interchange that. We make the y the x, and then we make the x the y. And then we resolve the equation for y. So in order to get y by itself, the very first thing you have to do is move that 3 at the end. So we're going to subtract the 3 over to the other side of the equal sign. When we do that, it doesn't combine with the x, it just gets written behind it. And then we would just rewrite the opposite side. We have y minus 1 squared left, because the 3's canceled right there. Now in order to get those parentheses to disappear so that I can move the y in the number, I have to get rid of the squared term. In order to get rid of the squared term, I have to do its inverse. Its inverse is square rooting. When I square root on this side, I really am just going to rewrite the x minus 3 with the square root over top of it. And when I square root on the other side, the squared and the square root cancel each other to just be y minus 1. One more step to get y all by itself. I'm going to add that 1 to the other side. Now that 1 is not underneath a radical, so it doesn't get to be under the radical with the x minus 3. It has to be thrown back behind. And then if you remember, we're not going to set it back equal to y. We're going to change that back to the function that it was, and that was a f of x function. And then just put that -1 on there to show that it was the inverse function of f of x instead of the original function. So those two problems are a review of yesterday, but just a point to be made on this, that the inverse function of a squared is a square root. The next thing we're going to do is look at what happens to the graph of that. So we're going to start by just filling out a table of values here for this function f of x equals the square root of x. Alright, so grab your calculators out and just plug it in with me. I'm going to substitute -4 in place of the x right there. And if I do that, I would square root a -4, and my calculator is going to give me a domain error. A domain error means that it's undefined there. We can't actually square root a negative number. It doesn't work that way. So we have no value of our graph is going to be at -4. There's nothing there. Okay, if we substitute in -3, the same thing happens. It's a domain error. We can't square root a negative number. Same thing happens with -2. The same thing happens with -1. But when we put 0 in, the square root of 0 is 0. So I just found my very first ordered pair. My first ordered pair is the ordered pair 0, 0. When I put 1 in and square root it, I get 1. When I put 2 in and square root it, I get the square root of 2, but if I were to get a decimal point number approximation for that, it would be 1 point something. The square root of 3 comes out as the square root of 3, and then the square root of 4 comes out as 2. Now in just a minute, when you graph these ordered pairs, you're just going to want to approximate their value to the closest decimal point number that you can. But here's what we're going to do. We're going to graph these to see what our graph looks like. But before we do, the question says, what did you notice about some of the values when you plugged them in? If you typed the function into the calculator and tried to evaluate it for some of the x values, what message appeared? And that was domain error. And the question is why? The answer to why is because we cannot square root a negative number without going into the imaginary number system. Then it says, let's just graph the graph provided with our ordered pairs. So our first ordered pair that we found was 0, 0. So you're going to put an ordered pair at 0, 0. Your second ordered pair is 1, 1. So you're right here at 1, 1. Then your 2 square root of 2, which is 1.4. The square root of 3 is like 1.7. And then if you're over at 4, you're up at the number 2. So you're right here. So if we were to graph our graph, it's going to look like this. Now, if we're looking at the domain and range of this, again, let's just talk about that. Domain is how far left does our graph go to how far right does our graph go. Where our graph goes left to here and then right to forever. So left would be 0 and right would be infinity. If we're looking at our range, it's how low it goes to how high it goes. So when you're looking at how low the graph goes, it doesn't cross the x-axis there, which means it's stopping at 0. And how high does the graph go? Well, it's going to continue to go up and up and up over that direction. So it's going to eventually make its way to infinity. So the domain and range on this graph look like they have restrictions, meaning they don't go forever in both directions. All right, this next one asks us to do the same thing with our table of values here. So we're going to substitute our numbers in and see whether or not we can get some answers out. So if I put -4 in, I would have -4 plus 2, which would be negative still, so I know that's going to be undefined. If I put -3 in, I would have -3 plus 2, which is still -1, so that's undefined. If I put -2 in, -2 plus 2 is 0. The square root of 0 is 0, so I finally found my starting point on my graph. My starting point is -2, 0. So I want to just bring up this point right here because this is where I've taught you how to use patterns. If you remember, when you have a number attached to the x inside a grouping symbol, it tells you to go left or right. So that plus 2 there, just like it did on all of our other graphs that we've graphed so far, asked us to go left 2. And you can see that by looking at the ordered pair that we just found. So our starting point here was left 2. Now from here I want to teach you, you can keep filling out those ordered pairs and you can figure out your ordered pairs to plot on this graph and then just go from there. But right here I want to take a minute and I want to remind you of a graph that we've already graphed. Now you guys remember a graph that was called the parabola. It was the x squared graph and it looked like this when we graphed it. It followed a pattern to get from one point to another. It started at the vertex point and it went over 1, up 1, over 1, up 3, and then over 1, up 5. So 1, 3, 5 was the pattern. Now we talked about this square root graph being the inverse function of the squared graph, which means it does the exact opposite. It's a reflection of the graph of the x squared graph over the line y equals x. So really what this new graph is going to do is it's going to start left 2 because we had that movement in there. Then we're going to follow the pattern up 1 over 1. And then up 1 over 3. And then up 1 over 5. Because my pattern actually gets to change directions from the x squared graph. So I can graph these graphs just by finding the starting point and following my pattern. So let's take a look at this domain and range again. Domain on this, it has a distinct starting point of -2 when you look how far left the graph's going to go, but it goes forever to the right. And then the range, you can't go down past the x-axis down here, so it's going to be starting at 0 and going to infinity on your range of your function. All right, let's see if we can do this next one without using the calculators, and just see if we can figure out where we know that our point's going to start at. Okay, let's substitute in -4 first and see what happens. If I put -4 in here, I would have 9 minus -4 squared. -4 squared is 16, but 9 minus 16 is a negative number, so I know I'm going to be undefined there. If I put -3 in there, -3 squared is 9, and 9 minus 9 is 0. So I actually just found my starting point. My ordered pair there for my starting point is -3, 0. So I'm starting right here on my graph. Now I want to do just a couple more ordered pairs because I'm wondering, and you should be too, if that negative on the x squared is going to change anything about our graph. So if I put 2 in, the -2, then -2 squared is 4. 9 minus 4 would be 5. So we end up with the square root of 5 right here. If I put -1 in, that would square to be a positive 1. So 9 minus 1 is 8, so I'd be at the square root of 8. If I put 0 in, I'd have 9 minus 0 squared, so the square root of 9, which is 3. So I have another ordered pair I can graph there now real easily, 0, 3. So go 1, 2, 3. And then if I put 1 in, I'd have 9 minus 1 squared. 1 squared is 1, so I'd be at the square root of 8 again. If I put 2 in, I'd have 9 minus 4, because when I square it, I would get the square root of 5. If I put 3 in, I'd have 9 minus 9, which is 0, and the square root would be 0. So I'm at 3, 0. Now I want to just bring up a point here that this time, when I'm graphing this, it looks a little bit different than it did before. Okay. Alright, so when I graphed this, I actually get a graph that looks like this time, just kind of a little half of a circle almost. So what's the domain of this function? The domain goes from -3 to 3, and the range of this function goes from 0. And how high does it go? It goes up to 3. So that's the domain and range of this function. Okay, so it says use our conjecture or our knowledge from doing those last few graphs to decide what the domain is of the square root of 2x plus 5. Well, we noticed that this underneath the radical had to be positive, so we know that 2x plus 5 has to be greater than or equal to 0. We can actually just solve that to find our domain values. So subtract the 5 over to the other side, and we get 2x is greater than or equal to -5. Divide both sides by 2, and we get x is greater than or equal to -5 halves. So really what that tells us is that if we're talking about our domain would start at a -5 halves, and it would go bigger than that to infinity, because all of our x values have to be bigger than -5 halves. So when we want to find the domain and we don't want to graph it, we could totally just look at what's underneath the radical and make sure that it stays positive. Okay, point to be made right here is what we're doing is we're taking an original graph, like the graph of x squared, which is this graph right here, the parabola that we've already learned how to graph, and we're reflecting it over the line y equals x. That reflection over the line y equals x is the inverse function, which in this case is the square root graph. This is the square root graph right here. But because of the domain restrictions on this, we actually don't get the whole graph. That's why this part of the graph right here is missing, because it gives us undefined values. So we only get that top side of the graph when we graph this. Okay, another point to be made too is that if we did graph both sides of this inverse function, this would not pass the vertical line test, which means it would not be a function anymore. And it wouldn't be the inverse function. So we have to make sure that our inverses pass the vertical line test. All right, let's just put this to work now and see what we can do. So the point again being is that in order to find the inverse of x squared, we have a restricted domain, meaning we're restricting it so that we only get the one side of the inverse function. Okay, so let's see what we can do really fast on these ones where we're just moving them left, right, up, and down, and I want to solve these ones by the pattern. Okay, our original graph is the x squared, or the square root of x function, which is that graph that goes like this, that starts at 0, 0, and it goes up 1 over 1, up 1 over 3, up 1 over 5. That's how we find the pattern there. So if I have a number added behind my function, that's telling me to move my graph up or down. The plus 3 tells me to start my graph not at 0, 0, but to start my graph up at 3 instead. So I'm going to start my graph right here, and I'm going to follow my pattern. I'm going to go up 1 and over 1, up 1 and over 3, and then up 1 and over 5. If I wanted to keep going, I would go 7 next, and then 9. 1, 3, 5, 7, 9 for my pattern. So this is actually what the graph of my square root function would look like if I add the plus 3 on the back. That plus 3 on the back, because it moved to up or down, would be a vertical transformation, which is what this question asks right here. Up and down is vertical, left and right is horizontal, and so that would be a vertical transformation, and it was up. Okay, this next one right here asks us to move either left or right. I know it's going to be left or right because it's directly attached to the x. And when we're directly attached to the x, we know the x-axis goes left or right. So that plus 2 right there actually moves us left 2. It's hard to remember why that happens. I've taught you a couple of different ways. I've kind of told you that it always just comes out of grouping symbols as the opposite. But really what we're doing is we're finding the ordered pair that makes this 0. And the number that makes the inside of their 0 would be a -2 value for x, which moves us left 2 to be over at -2. So once you decide that you're moving left there, you're just going to follow your pattern. You go up 1 and over 1, up 1 and over 3, up 1 and over 5, and you graph your square root function through those ordered pairs. Because we moved left, that was a horizontal transformation. All right, one more to look at right here. This time I have a 2 out in front of my function. This function right here is represented as a y value. F of x represents like a y value. So what this is asking me to do is multiply my y values by 2. So I didn't move left or right, and I didn't move up or down. So I'm starting at 0, 0, and I'm moving my y values by 2. So normally I would go up 1 over 1. Up 1 over 3, but because I had that 2 out in front, I have to change my up values by multiplying them by 2. So I'm going to go up 2 and over 1, up 2 and over 3, and then up 2 and over 5 for my graph to go through those ordered pairs instead. Because we changed the y values again, it's vertical. It's a vertical transformation. All right, so let's see if we can put this all together and just use it really simply Just a reminder up here that this is the vertex form of what a square root graph should look like. The h and the k value tell you where to start. So how far left and right to go, how far up and down to go to start at your vertex. The a changes the pattern. It is a vertical stretch by a factor of a, meaning change how far you go up and down on your pattern by that number that's out in front. So let's just look at this one right here. The -1 tells me to go right 1 because it's inside the grouping symbols directly attached to the x. The -2 outside here goes down 2. So instead of starting at 0, 0, I'm going right 1 and down 2 for my starting point. Because there was not a pattern change out in front, I can follow my same pattern, which is up 1 over 1, up 1 over 3, and up 1 over 5 to graph my square root function. If I'm going to list the domain and range of that, my domain starts at 1, because how far left does it go? It goes to 1. How far right does it go? It goes to infinity. My range is how low it goes to how high it goes, and it starts at -2 and it goes to infinity. All right, last one here, I think. We have 2 times the square root of x plus 4 minus 1. The plus 4 asks you to move right 4. The -1 asks you to go down 1. And the 2 out front says multiply all my y values by 2. So I'm going to start right 4 and down 1 for my ordered pair, for my vertex point. And then instead of going up 1 over 1, I'm going to go up 2 over 1, up 2 over 3, and then I would go up 2 over 5 if I were doing another ordered pair. So my domain on that is how far left do I go to how far right do I go. Well, my domain starts at 4 and goes to infinity, and my range starts at -1 and goes to infinity. Thanks for sticking with me on this note-taking guide. I know that was a lot of information. If you're still having trouble, please come and see Mrs. Clark.